Okay, we're going to talk about chemical equations. And in chemistry, when you're looking at a chemical equation, you should be looking at it as a recipe or a storyline or a way of chemists of telling what is actually happening in the chemical reaction. And I'm going to write a very simple chemical reaction up here on the board so that you can see and we can discuss what all the pieces mean. Okay, we have hydrogen, and we have some oxygen, and we have H2O. Before I get any further, why did I write a subscript of 2 here? Oh, that's right, because it's one of our 7 diatomics. Same thing with oxygen. This 2 right here is not written there because hydrogen is a diatomic. It is written there because the oxidation number of oxygen was a -2, and I crossed it down. And hydrogen was a +1, and I crossed it down. If the element is by itself and it's a diatomic, you will put a subscript of 2. If the element is in a compound, it gets its subscript from its partner's oxidation number. Keep that in mind. That's just a little bit of review right there. Okay, what does this story or recipe tell us? It tells us that the stuff that we have on the left side of the reaction is what we are starting with. We are starting with hydrogens, we are starting with oxygens. And those things that are on the left side of the reaction are called reactants. Okay? Then we have this arrow, and the arrow generally will be referred to as yield, okay, or become, or creates. Okay? So hydrogen and oxygen creates, yields, produces water. And this side of the reaction is called the product. It is what we are producing. We don't have this and this at the same time. This is what we have before the reaction takes place, then some chemistry magic takes place, and we are producing water. Okay, that will be a different story when I have the arrow going in 2 directions, but we'll get to that in a later program. Alright, now if you recall, there was a law that we talked about previously called the law of conservation. And the law of conservation states that what I have when I start has to be what I have when I end. And in this case, I do not have the same amount of stuff in my reactants as I do in my products. Let's take a look more carefully or more closely. Okay? Right now, I am saying to you, you have 1 mole of H2, and then there might even be a little symbol after here to make it even more interesting story. It might say 1 mole of hydrogen gas, that G stands for gas, plus 1 mole of oxygen gas produces 1 mole of water gas. Okay, that could be liquid water as well, but I chose gas. Okay, depending on the energy exchange. So when I have this formula up here, or this chemical equation with these formulas in it, I can see that I have 1 mole of hydrogen gas that gives me 2 hydrogens. On the product side, I have 2 hydrogens. Now they're rearranged and they're tied up in a water molecule. Here I have 1 mole of oxygen, which is made of 2 atoms of oxygen. But over here, I only have 1 atom of oxygen. Well, where did that extra oxygen go? Another way to look at this, in case that you still don't understand what I just said, is let's say I had hydrogen here, and hydrogen's diatomic, so it looks like that. I have 1 mole of it, so we diagram it as 2 hydrogen atoms just barely touching each other. And I have 1 oxygen, 1 mole of oxygen, so 1 oxygen. Again, it's diatomic, so I have 2 of these oxygens barely touching each other. If I go to draw the water molecule, now I have 2 hydrogens and 1 oxygen. Well, what happened to this other oxygen atom? It didn't disappear. It can't disappear. The law of conservation tells us the stuff that I have in the beginning has to be the stuff that I have at the end. And right now, I have 2 oxygen atoms, but I only have 1 oxygen atom over here. So we have to learn how to balance a chemical equation so that we can get the number of atoms on the reactant side to be equal to the number of atoms we have on the product side. And there is a very intricate series of steps that we're going to take to balance a chemical equation. But they're not very hard, they're just a series of steps that you have to get used to. So I'll just read through them, and then you can pause the tape, and you can study them, and you can practice them. But let's look at the steps together for a second. Let's say step 1. We're going to draw a line to separate the products from the reactants. And I'll show you how to do that in a second. Then we're going to list each of the different elements on each side of the line in the same order. And in the same order is important, and you'll see why in a few minutes. Okay, step 3. You're going to count up the number of atoms on each side and record that number next to the element's symbol. Step 4. Balance the elements found on one side of the line to the atoms found on the opposite side of the line by changing the coefficients for the different species in the equation. Species is a fancy way of saying the hydrogen or the oxygen or the water. Okay? And then every time you change a coefficient, you have to recount everything. And that's a little bit tedious, but it's not that hard. And then step 5, continue doing this. Continue balancing them until you have the same number of each element on both sides of the equation. So it sounds like a lot of work, but it really isn't that bad. And actually, I like doing this. This is a lot of fun. Okay, so let's try one so you can see what I'm talking about step by step. You see this H2 plus O2 yields H2O. That's what I just had over here on the board. So I'm going to see if I can bring that back. And when I bring it back, I'm going to use that so that I don't have to redraw it for you. Okay. Some of you might be asking what a coefficient is. Coefficients are these numbers right here. The 1, this 1, and this 1. The coefficients are numbers that we can make anything we want. We can make a coefficient of 5,682 if we felt like it. I have to write that plus sign back in. Okay? Whoa! Hello. What happened there? Okay. There we go. So I can make these coefficients any number I want as long as the equation is balanced, meaning the number of hydrogens that I have on the left is going to equal the number of hydrogens that I have on the right. The number of oxygens I have on the left is going to equal the number of oxygens I have on the right. What I cannot change is I cannot change these subscripts, because the subscripts come from, these 2's came because they're diatomic atoms, or diatomic elements. These subscripts came, the 2 and the 1 that you can't see, came from the oxidation numbers of hydrogen and oxygen. We cannot change the bottom numbers, ever, ever, ever. They come from oxidation numbers, so don't touch them. Only touch these numbers up in front. Alright, let's take it step by step so that we can show you how this works. We're going to do a bunch of these. We've got step 1, draw a line to separate the products from the reactants. A nice straight line. Not too straight, but you can do a better job when you're not drawing on the computer. So we've got a straight line that separates the products from the reactants. That's step 1. Done. Step 2, list each of the different elements on each side of the line in the same order. So on this side of my equation, I have hydrogen and I have oxygen. On this side, I have hydrogen and oxygen. They happen to be written in the same order, but they will not always be written in the same order. So make sure that you line them up. Hydrogens, then oxygens. Okay? It's very important. It'll be much easier for you. Okay, step 3. Count up the number of atoms on each side and record that next to the element symbol. So over here I have 2 hydrogens and I have 2 oxygens. On this side, I have 2 hydrogens and I have 1 oxygen. Did I say hydrogen? 2 hydrogens and 1 oxygen. So that's step 3. So we're already up to step 4. It's pretty easy so far. Pause the tape if you need to. Study what I'm doing. Okay. Balance the elements found on one side of the line to the atoms found on the opposite side of the line by changing the coefficients, and there's the key, for the different species in the equation. And remember, I said species is just a big fancy way of saying number of hydrogens, number of oxygens, or number of waters in this case. So I can put a number here. I could put a number here, and I could put a number here. And those numbers are going to change these. Alright, hydrogens are balanced. There's 2 hydrogens here, and there's 2 hydrogens here. So I don't need to touch those. Let's look at the oxygens. There's 2 oxygens here. There's 1 oxygen here. They are not balanced. I need to get them to be the same number. So what I'm going to do is I'm going to place a number in front of the species that has the lower number of oxygens. In this case, it's the water over here. And when I place a number there, that number is going to change the number of oxygens because those coefficients multiply through so that it changes all of the numbers in this species. So if I place a 2 here, that 2 changed the number of hydrogens that I had because now I'm going to have 4 hydrogens, and it also changed the number of oxygens that I had to 2 oxygens. So step 4 still, we are going to recount these numbers down here. So when I get 2 H2Os, I now have 4 hydrogens. And 2 H2Os give me 2 oxygens. Recount everything. Now my oxygens are balanced. Now continue balancing the elements by changing coefficients until you have the same number of each element on both sides of the equation. But by putting the 2 here, the hydrogens came out of balance. So I have to go back up to here, find a place where I can change the hydrogen. I always work on the side with the lower number. So this is a 2 and this is a 4. So I'm going to put a coefficient in front of this hydrogen. So when I do that, I'm going to choose a 2. I could choose any number I want, okay, but I wouldn't suggest picking 5,684, okay, pick nice low numbers. That 2 times this 2 is going to give me 4 hydrogens. That 2 does not affect this oxygen, but I suggest that you get into the habit of checking everything. Recount everything. So we've got 2 times 2 hydrogens and 1, there's a 1 here, you can't see it, 1 times 2 oxygens, so that stays the same. Get in the habit of recounting everything. When you put a coefficient in, recount everything on that side. And the same goes with when you put a coefficient on the product side, you want to recount everything. Okay, so there's a 1 here. There are 4 hydrogens, 4 hydrogens. 2 oxygens, 2 oxygens. The equation is now balanced with the coefficients 2 to 1 to 2. Just like in an empirical formula, we want these numbers, these coefficient numbers, to be the smallest whole number ratio to each other that they can be. 2 to 1 to 2. So if you came up with numbers that were not smallest whole number ratios, let's say you decided to put a 4 here. 4, and this was a 2, and this was a 4, you need to reduce those to 2 to 1 to 2. I've seen people lose points on a Regents for doing that. So make sure that these numbers are the lowest whole numbers that you can make them. Even if you decided when you were balancing to use bigger numbers, reduce them at the end. Okay? So it's not that difficult, it's just a series of steps that we have to work through. Alright, let's try another one. Let's see, I need a... And this one... let's scroll down here. This one, a little bit more complicated, only because it's got 3 elements in here now. So, step 1. draw a nice straight line. Right? Nice straight line, just like I did. Okay, then you're going to make a list. Whoa! What's that? I never saw anything like it in my life. Okay, so we've got that straight line. Then we're going to draw the elements: magnesium, hydrogen, and chlorine. I'm going to rewrite the elements on the product side in the same order. Now look, if I go in the order that they're up here, they're not going to be in the same order in my list. Magnesium and then chlorine and then hydrogen. It makes it much harder to compare to see if things are balanced. So I'm going to keep them in the same order down here in my list. Alright, let's count. 1 magnesium, 1 hydrogen, 1 chlorine. Right now there's ones here. It's not balanced. Oh, I didn't put a squiggly line there. 1, 1, 1. Now let's do this side. 1 magnesium, 2 hydrogens. See the 2 hydrogens there? It's diatomic. And chlorine, there's 2 of them. This is not diatomic chlorine. This got a 2 because the magnesium has a +2 charge. If you don't believe me, look in your periodic table. In the periodic table, magnesium has an oxidation number of +2. See it right there? So it gives chlorine a subscript of 2. Chlorine has a -1, so there's a 1 down here. Okay, let's get to balancing. Alright, magnesiums look balanced. Let's look at hydrogens. Not balanced. So we're going to work on the side with the lower numbers. So this hydrogen has a 1. What can I put in front of this hydrogen that's going to change the hydrogen to a 2? I'm going to put a 2 in front of that hydrogen. And when I do that, stop everything and recount. There's still 1 magnesium here. There's 2 hydrogens. There's 2 chlorines. Okay? Recount everything. You don't have to recount this side because I didn't put a coefficient on that side. Now, we're done with this 2. Magnesium is 1. Magnesium is 1 on the product side. 2 hydrogens on the reactant side. 2 hydrogens on the product side. 2 chlorines on the reactant side. 2 chlorines on the product side. This guy is balanced. Okay, he's happy. You have law of conservation. You have the same number of atoms on the reactant side as you do on the product side. Okay, let's clear this and let's try another one. Now, the next one is definitely more complicated. Okay, this one is not going to be as easy for you, but I'm going to show you a little trick to doing this kind of equation. So let's take the line and write our elements: carbon, hydrogen, oxygen, in the same order: carbon, hydrogen, oxygen, and then we're going to count 2 carbons. See the 2 carbons right here? 6 hydrogens, 6 hydrogens, and 2 oxygens. On this side, I have 1 carbon, I have 2 hydrogens, and I have 3 oxygens. Now, you might say to yourself, why do I have 3 oxygens? Well, there's 2 oxygens right here in the carbon dioxide, and there's 1 over here in the water. Even though they're separate, there's still an oxygen atom, so you have to count them as 1. Okay, that's what's making this so much more difficult, that the oxygens are spread out. Alright, when you do this problem, I suggest that you start with the carbons and then you leave the oxygens for last. So let's do carbons first. Here's 2 carbons here, there's 1 carbon here. I need to get this number of carbons to equal 2. So I'm going to go up into my coefficients and I'm going to place a 2 right here. I'm going to stop everything and I'm going to recount. This carbon became 2. There's 2 carbons now. This right here became 4 oxygens. But I have another oxygen over here still. So I didn't become 4 oxygens, I became 5 oxygens. And then my hydrogens didn't change, they stayed 2. So you can cross that out and just rewrite it so that you have them all right there. I like to cross these out so that I don't get confused. Okay, now I have carbons done. Now, hydrogens are only in one place. Oxygens leave for last. So hydrogens are right here. You have 2 hydrogens on the product side. You have 6 hydrogens on the reactant side. I want to get the number of hydrogens on the product side to equal the number of hydrogens on the reactant side. So since I want this 2 to become a 6, I'm going to multiply it by 3. And then I'm going to stop everything and recount. Okay? It's sometimes helpful if you just cross everything out and recount everything. Okay, 2 carbons. We've got 4 oxygens here, and then now we have 3 more oxygens over here. So that gives me 7 oxygens. Hydrogens, I have 6 hydrogens. Okay, looks good. 2 carbons, 2 carbons. 6 hydrogens, 6 hydrogens. Oh no, oxygens don't match up, and there's nothing I can multiply this oxygen by to get to 7, because I have a 2 here. So whatever number I multiply it by is never going to give me 7, if it's a whole number. Okay, and this is where the trick comes from. If I take this oxygen and I want to get it to be 7, like it is on this side, I have to multiply this by a fraction. And that fraction is 3.5. 3.5 times 2 gives me 7. Recount everything. Okay? 2 carbons, 6 hydrogens, and 7 oxygens. Okay, that wasn't so bad. Except we ran into a little bit of a problem here, because you have coefficients that are not whole numbers, and that's not allowed. So what we have to do is we have to make these coefficients whole numbers, especially this one, right? So to get rid of this half, I'm going to multiply everything by 2. And that's the trick. So instead of a 1 here, I'm going to put a 2. Instead of a 3.5 here, I'm going to put a 7. Instead of a 2 here, I'm going to put a 4. And instead of a 3, I'm going to put a 6. So the lowest whole number coefficients, the lowest ratio that I can have, is going to be 2 to 7 to 4 to 6. Okay? That one was a tricky one. Stop the tape, pause it, try it on your own, see if you can get it. It will always come as a half here. Okay, so don't be too worried about that. Alright, let's try one more example before I stop the tape. Let's get rid of this. And let's go to the last example. Now, the last example looks the most complicated, correct? But actually, the one we just finished was more complicated than this one. Alright, now with this one, I'm on a pen, right? Am I on a pen? Yeah, I'm on a pen. Okay. On this one, we are going to have to deal with polyatomic ions. In this case, we have aluminum sulfate, and the sulfate right here also shows up as a sulfate on the product side. So, polyatomic ions travel as a group. They don't split up. I don't say ever, but in this case they didn't split up, because you've got sulfate ion here, you've got a sulfate ion here. You have a hydroxide ion here, and you have a hydroxide ion here. They didn't split up, so we're going to treat those as if they are a single element. So let's make our list. Let's take aluminum and sulfate. See how that SO4 stayed as one whole unit? And then we have calcium, and we have hydroxide. Okay, on this side, we make the same list. Aluminum. Now, if I was following along up here, I would want to write OH here, but I don't want to do that. I want to keep the list exactly the same as what I have on the left side. We've got SO4, we've got Ca, and we've got hydroxide. Okay, so we made a line, we drew a list on both sides of the equation. Now we're going to take and count. We've got 2 aluminums and we've got 3 SO4s. We've got 1 calcium, so the subscript of 1 here, that's not written, and we have 2 OHs. Okay, on the product side, we have 1 aluminum, we have 3 OHs. Make sure that you write it in the right place. We've got 1 calcium, and we've got 1 SO4. Okay, so we have all of our information. Now we can go ahead and we can write in the coefficients. I'm going to start at the top here just with the aluminums because it's the first one on my list. No other reason. I could start anywhere I want. I generally like to leave oxygens for last, but we don't have any oxygens in this question. So let's take aluminums. I'm going to work on the side with the smaller number. This number is 1, this number is 2. So I'm starting on the product side. And I'm going to add a coefficient to the product side. How do I get this aluminum to be 2? If I put a 2 there, that changes this aluminum to 2. Recount everything. Cross these off. Make believe they don't exist anymore. Once you put a coefficient in, you have to recount. So 2 aluminums, and now I have 6 OHs. Calcium and sulfate didn't change, so I have 1 sulfate and I have 1 calcium. Okay, let's move down the list. Let's take care of the sulfates. Again, my lower number is on the product side. I'm gonna work on the sulfates. I want 3 sulfates. So I'm going to put a 3 in front of the calcium sulfate. And then I'm going to recount everything. 2 aluminums, 6 hydroxides, 3 calciums, and 3 sulfates. Okay, moving down the list. Calcium and calcium. Now I'm going to work on the reactant side, because there's 1 calcium here and 3 calciums here. These guys are balanced. See, 2 and 2, 3 and 3. So I'm moving down the line. Calcium is 1 on the reactant side and 3 on the product side. So I'm going to be putting a coefficient in front of this calcium. I'm going to place a 3 there. And when I place a 3 there, I recount everything. 2 aluminums. There's still 3 sulfates. Now there's 3 calciums. And 3 times 2 is 6 hydroxides. Oh, look at that. 2, 2, 3, 3, 3, 3, 6, 6. It's a beautiful day. The whole thing is balanced. Okay? What is the coefficient that is here? Right, it's a 1. Don't forget there's a 1 there. If there's a 1, you don't have to write it, but you have to understand that it's there, because one of the tricks that the Regents exam does is they'll ask you, what is the sum of the coefficients? If you didn't have the 1 here, let's say that you didn't put it in, and you just looked at this and they said, what is the sum of the coefficients? Sum means add them all together. And you add 3 plus 2 is 5, plus 3 more is 8, and you say, oh, it's 8. No, it's not 8. Because there is a 1 here, okay, the answer is 9. 3 plus 3 is 6, plus 2 plus 1 is 3, so 3 plus 3 plus 3 is 9. Don't forget those 1s as your coefficients. They're very important. The other thing that they can ask you is, what is the coefficient in front of aluminum hydroxide? Well, look at your actual formula. This is aluminum sulfate. This is aluminum hydroxide. So knowing the names of those polyatomic ions helps you with that question. Okay, hopefully we get to some of those in a guided practice later on. Okay, I hope this helped. I will talk to you in the next video.